Why do we have to know all these things? Well, it is kind of an English class. We have to learn the correct terminology so that we all speak in the same language. So we all talk about the same things. Okay, and down the bottom here, there's all of these are polynomials. All of these make up polynomials. But these ones are special. They have special names. If it only has one term, that's called a monomial. So mono for one. Two terms, we call those binomials. Those are special. They only have two terms. Again, separated by an add or subtract sign. That's a really important part. And a trinomial has three terms. So it's separated by a subtract here and an add here. So 1, 2, 3. Anything more than 3, we just call them poly. We call them many. Poly means many. So polynomials, you can refer to all of these as polynomials, but usually when they're 1, 2, or 3, they go by the special names of monomial, binomial, and trinomial. Okay. Fun times. I know you're excited. And I handed you guys out something called algebra tiles. And algebra tiles are a way to represent the algebra. Oh, this is a lot of words. Let me zoom in. And we covered a lot of this already. All right. So all the terms that we're talking about, all the language that we're talking about is going to be on this first couple of pages. So I don't know if you want to highlight stuff or you know it already. We talked about polynomial. It's an expression, so that means that there's no equal sign. No equal sign with one or more terms. Okay, it could be a monomial, could be a binomial, could be a trinomial, or it could have 17 terms in it. That's a polynomial. So it's just the word that encompasses everything. We use variables in algebra. So a variable is a letter or a symbol that represents an unknown value. X is really, really common. Y, N, it doesn't matter what it is. It's just we don't know the value of it and we're putting something in its place. Exponent, superscript. Superscript just means that it is high and on the right. Superscript. Subscript is when it's low and usually on the right. So superscript, we know what that means. We know that it has a base of 3. We know that 3 is multiplied by itself 4 times, right? We know that that means 3 times 3 times 3 times 3. Just like if I had x to the exponent 3, that would mean x times x times x. So those things mean the same thing. It doesn't matter that we don't know what the base is. The exponent's telling us that we multiply it by itself. Okay. So degree. The degree of a polynomial is going to be your highest exponent. It's going to be your highest exponent. That's the degree. We talked a little bit about a constant. A constant is a term that has no variables and usually is just a number. The coefficient of the variable, oh, there's too many negative signs in here. Let's get rid of that one. The coefficient is the number in front and it tells us how many of the variable we have. So the coefficient would be -3. We have -3x squared. So you're like, Scallion, that makes no sense. But it will make sense when we start using the algebra tiles. We're going to go through those and learn how to use these ones. Okay, terms, always separated by an add and subtract, not a multiply and divide. They are separated, I'm going to use my highlighter for this one, separated by addition and subtraction signs, never multiply and divide, just the addition and subtraction. Okay, we talked about monomials. It has one term. A binomial has two terms, the 5x and the 3x, and a trinomial has three terms, so 5x squared plus 2x plus 3. They're all separated by addition signs, so 3 terms. All right. Sliding up here. We've done this before. The term with the greatest exponent. So maybe let's move to this one. The degree of this polynomial, is what? What's the highest exponent? Anybody? Looking at this one? What's the exponent on this one? 2. What's the exponent on this one? If it's invisible and we can't see it? 1, that invisible number 1. And this one doesn't have an exponent. Well, or this one could be x to the exponent 0, because we know anything to the exponent 0 is 1. We learned that in our last unit. So what's the highest degree? 2, 1, or 0? Or what's the highest exponent, sorry? 2. So we would say that this polynomial has a degree of 2, because it's the highest exponent. All right, so, and we usually write polynomials in descending order of exponents. So what does descending order mean? Highest to lowest exponent. That's like proper math grammar. Proper math grammar. Okay. We good to turn the page? So that's all like the fun stuff that you need to know, the language, the terminology, and your polynomials. So we would write, like if it was given as 2t minus 4t squared plus 7, we change it. And this is a really good point. Your terms include the sign in front of them. So this would be a negative 4t squared. We'd write that first. If there's no sign in front of the 2, we would know that that is positive, so it'd be plus 2t, and then we'd have plus 7 at the end. So our constants always are at the end. Okay, now we're going to use our knowledge of things, and we're going to write a polynomial for this situation in example 1. Jack is 3 times older than James. Okay, why is that Dan? Let's get rid of Dan there. Let's write Jack in here. I don't know who Dan is. All right, so Jack is 3 times older than James. Morning. Okay, so what do we know about Jack? What do we know about Jack? He's 3 times older. So do we know how old James is? No. So we're gonna say James, we're gonna represent James by the letter J. How does that make you feel? And we know that Jack is 3 times as old. So we're gonna write 3 times J. Now in algebra, and that's it, that's the whole polynomial, nothing special about it. We can write it as 3j. We could write it as 3 times j over here. This was the only one that I wouldn't encourage you to use. I wouldn't encourage you to use that one because x is a variable, so I probably wouldn't use that one. You could, if you butt them right up against each other, in polynomials in algebra, that indicates that they're multiplied. You can use the dot or you can use the bracket, but I wouldn't use the x as a multiply just because we use it a lot in like for a variable. Okay, so now I've given you the polynomial. Could we create a situation that would be represented by it? It really could be anything, guys. It could be, sorry, just distracted by the lockers. I don't know what's going on there. Okay, so maybe an idea might be Kelly has 4 times the amount of pencils, because we're math teachers and we like pencils. Kelly has 4 times the amount of pencils than Miss Denny, who is right next door. I think I missed a Y on Miss Denny's name. But less 5 pencils. So I have 4 times as many, but less 5. So if Miss Denny had 10, how many pencils would I have? 4 times 10 is 40, minus 5 is 35. So I would have 35 pencils. Miss Denny would only have 10. Ooh, forgot to pluralize my pencils there. So it really could be any situation. But all I know is that I have 4 times as much, but less 5 of them. So I don't quite have 4 times as much. Okay, that's a little bit confusing. Creating the situations can be confusing. I'm probably going to ask you to do this a lot. I'm probably going to ask you to do that a lot, more example 1 than example 2. So you can expect to see that on a problem set or on your test. Okay, now the fun stuff. You guys are like, none of this is fun. Hey, Devin, how's it going? There's one on your desk for you. Okay. We're just going to keep this off to the side because I'm going to, Devin, you came close and I sent you away, but you need some as well. Okay. All right, so everybody's going to empty out their algebra tile bags for me. Do you guys remember base 10 rods from like elementary school? You had the 10 and then you had the ones, and 10 ones made up a stick, and then 100 ones made up the square. This is the same sort of thing. Ours are a little different. You see that they're 2 colors. The squares are blue, the sticks are green, the ones are yellow. But on the other side of them, they're all red. Okay? So in algebra tiles, now we're kind of same sort of premise as base 10 blocks, but we're doing it for unknowns. Okay. So let me grab a stick for a second. If I line up along the stick, oh, you guys can't see that. There we go. If I line these up, if I line up the ones against the stick, it's almost like 5, but is it exactly 5? If you were to look at that, if you line up your ones against the stick, is it exactly 5? No. So we don't know how much it is. So this is an unknown. What we do know, though, is that it has a width of 1. a width of 1. Oh, look at this. You guys can't see my top there. Okay, so if I were to do the area model for the stick, I'm just going to draw my stick here. We know that it has a width of 1, because these are our 1 unit cubes, has a width of 1, but we don't know how long it is, so we're going to say x. Now to find area of a rectangle, it's length times width. Area is length times width. So if I have the area, length is x, and the width is 1, so that's going to be 1x, and we often write that as just x. So we know that the sticks are x's. So the stick is x, the little unit cubes are 1, and then if I go to my big one here, if I go to my big blue ones here, what you'll see is that the width is exactly x, and the length is also exactly x. So if we did the area of this one, so area of a rectangle or a square is length times width. So we know that these are x's, so x times x. Those have invisible exponents of 1 on them. And so that's going to be x squared. So we know that the big ones, the big squares, these are x squareds. These are x's, these are x squareds, and these are 1s. All right, so now that you know what all the shapes represent, their colored sides, so the blue, the yellow, and the green are the positive, and the red sides are negative, okay? And that will come into play when we do tomorrow's lesson that you're going to watch the video for, and it will come into play when we do Friday's lesson. All right, here we go. So it says, I want you to model 3x squared minus 2x plus 5. So 3x squared minus 2x plus 5. All right, so what we need, we know that these are the squares. These are the sticks. Ooh. And these are the unit squares. All right. And remember that we have to take the sign in front of it. So this one, will they be blue or will they be red? For the 3x squared, will they be blue or will they be red? Is the 3 positive or negative? Positive. Positive. So they're going to be the blue. Remember, red represents negative. And then if I look at the 2x, remember that you got to take the sign in front of it. Are those positive or negative sticks? Those are negative sticks because it's got the subtraction sign. So what color will these be? These will be red. And then these guys at the back, we take the sign with it. So if we were to represent this, I would need 3 of these. Hopefully you all have enough. Oh, I'm not zoomed out enough. Let me zoom out a bit. Let me get all mine on there. There we go. So I need 3 of those. I need 2 sticks, but the sticks are -2, so those have to be red. And then I need 5, and these ones are positive, so these ones are going to be yellow. One, 2, 3, 4, 5. Okay, so I've modeled that. Did you guys get that same model? Sorta, kinda? Okay, so we're just taking a polynomial and we're putting it to shapes. And we gotta decide what color. Remember, red is always negative. Red is always negative. Okay, so we've done that one. I'm gonna clear off my thing. The next one we're supposed to model is 2b squared minus b plus 4. Okay, I'm not going to help you with that one. You guys are going to do it. Going to do it. And then I'll show you, but you guys do it. Oh, maybe I'll freeze. I'll freeze this. Does it matter that it's a b squared instead of an x squared? The answer is no, it does not. It's an unknown. We don't know what it is. I know it might seem silly using the tiles and stuff, but it really is helpful. It really is helpful. And you'll get to a point where you don't need the tiles anymore, but we'll all get to that point at different times. I still like using them because it really does help you see it. Okay, are you guys ready to see the answer? Yes? Did you have one red stick? Because we know that there's an invisible number 1 right here. And everybody else is colored, which is super exciting. Okay, model the next one. The next one is, so we're done that one. The next one is 5a minus 3. 5a minus 3. Try it. Try modeling it. I don't know if I have enough sticks. Maybe I do. Is that what you guys got? And the colors matter. The colors matter. That minus 3, that means that we have 3 negative constants. We have 3 negative constants. So your reds, your unit 1 should be red. So there's no squares on this one. That's nice. Okay, last one. Last one is going to be 3x squared minus 5x plus 6. I'm in a room. Oh, jeez. I did mine wrong. Wasn't paying attention. All right. You guys ready to see the answer? So that's what I got. That's all the ones I had in my package. And that's it for this lesson. I'll go in and draw these notes in so they look a little bit better. Ladies and gentlemen, let's make a decision. You guys are going to have to draw these models out. You can use the models to help you, like the actual physical ones to help you, but for your assignment, you're going to have to draw them out. So let's say not shaded. Not shaded is positive and shaded is negative, because we're probably all dealing with pencils, right? So not shaded stick, if I have an unshaded stick, we'll say that is a positive. And if I take the stick and I shade it in, we'll say that that's a negative. Is everybody okay with that for your assignment? Okay, so today you're just drawing pictures for your assignment. If you want to use the algebra tiles, feel free to keep them. If you're done with them, you can package them back up and put them back in the bin. This is the beginning of algebra. Algebra. So excited. Wait till we multiply and divide. No? Nobody's excited about that? All right.